AI is math, or rather, an abstraction of math. It's really an abstraction directly on the programming languages that we already kind of know that exist. It encompasses these programming languages, similar to like how these programming languages themselves use libraries. And after we get through some of the lowest level programming languages, we eventually reach our machine code, which is going to be our ones and zeros, or rather, our math. And in this video, we're going to cover some of the most basic data types that are included with C. And you can almost see along the way that everything is a interpretation in terms of yeses and nos, just like our on and off switches that we have. We'll even touch on quantum computing and how that plays a role in this, but we're going to assume that you don't. So what are some of these primitive data types that C inherently provides, and rather really gets us to be able to talk to the hardware on its own? Those are going to be void, which is really just nothing, and then some of our numbers, such as -3, -2, -1, and then so on, and floats, which are basically decimal point values, doubles, which are going to be more precise decimal point values, so they're going to use more memory, are chars, and really not strings. What's happening when we use our string, or we rather declare that the return of our getString function from the CS50 library is a string, this string data type itself is coming from our CS50 library. It instructs what data type that return is and makes it for us. It really ends up being a bunch of chars at the end of the day, or rather characters, which are just like letters. We begin seeing how data can start being described in terms of what the bytes contain. And each of our data types, as we get more and more outside of our abstraction onion, are going to take more and more data, the more abstracted they are. So our void, of course, is going to take 0 bytes because it's literally nothing. Char is going to take 1, as well as shorts. And then ints and floats are going to be up to 4 bytes. And you can even go beyond there when creating your own data type eventually. We see these very similar. You can think of your compiler, because that's really what's doing the magic here, is we are turning our source code into this binary code. But really, before we actually reach that binary, we have to hit a number. And each of these data types, the primitive ones, are using numbers to represent characters, shorts, etc., different types of data. And based on how many bits that each of these data types gets will determine the range of possibilities of numbers that that data type can have. And that's why we see that our